Hello, this is Safakhan from safakhan.com, and this is part 4 of the tutorial series on making a tower defense game using processing 2. In this video we're going to work on creeps, their sprites, and animations, and having them run along the path that we created in the last video. So let's open up our sketch folder, and there we'll find the data folder, which, by the way, if you don't already know, all the files in the data folder are freely available at my website, safakhan.com. So within the data folder there's the creeps folder, and that's where our creeps are. So let's open one of them up and take a look at the naming convention. So this creep is named Gob, so it's within the Gob folder of the creeps folder, and then each sprite is named Gob, and then underscore, and then first initial of a direction, so down, left, right, and up, and then either 0 or 1, so which frame of the animation it is. So we're only working with 2-frame animations, so it'll look just like that in action. And yeah, so let's start working on that. We're going to go create a new class, so we'll do that in the classes folder tab, and this class will be called creep sprites. Creep sprite, singular. And this is going to store 4 different arrays of p images, and each array will correspond with a direction. So check it out. P image, and then this will be up as a new p image array with a capacity of 2, 1 for each frame, and then we'll do the same thing for each direction. So down, left, and right. Alright, so let's make the constructor, and this will take in a string. That's the name, and then with that we'll just work out the rest. So first thing that we'll do is create a new string that's equal to the file path, so we'll just call it path, and so we'll do name plus, or I'm sorry, creeps slash, and then name plus another slash plus name again, and then underscore. Alright, so with that we could start loading them in, and so here we go. So we'll do up 0 is load image, and we'll just pass in the path plus u0, oops, for the string u0 .png, and we'll do the same thing for u1.png, except we'll load it into up1. Alright, so we could just copy that and paste it for each direction. So this would be down, down, D, left, L, and then finally right. Okay, so that's it for now for the creep sprite class. Let's jump back over to our main tab and create the creep sprite array that will store all of these. So again, it'll be done similarly to the way that we do tower sprites where it'll store all the information, and then any creep that wants to use it could just reference this array when it wants to draw itself. So we'll just call it creep sprites, plural, and we'll initialize it in setup just underneath or after where we did the tower sprites. Alright, so we'll do new creep sprite, and we'll pass in gob as the first one, and then check it out, I've got another one called Ticky, so we'll load that one in too. So let's test it out, make sure that I don't have any typos, and it looks like we do. Let's see, could not find anything. Oh, I'm sorry. These are strings, so let me just put in our quotes. Alright, so it looks like it's loading up. Alright. So, the next thing that I want to do, before we go any further with creating classes, I'm going to create a new tab, and I'm going to call this enums.java because we're going to create a new enum. So, and the reason that I'm doing it in a new tab is because I ran into some problems with working with enums unless it's in a tab that ends in .java. So make sure that you include that there. So yeah, so we'll just use this for our enums, and this is just going to be an enum called direction, and it'll just be one for each direction, so up, down, left, and right. Alright, so now we're going to backtrack on what we did in the last video just a little bit. We're going to create a class called path, and yeah, so let's go to our main tab and check this stuff that we worked on in the initialize path function, and let's just cut that, and we're going to use that as our constructor for this class path. So we could just delete this portion, and that should be working constructor. But let's actually store the pathway here, and where we were storing the pathway before, we're gonna change that around a little bit to store a path, and we'll call that level. Alright, and now we can start working on lanes, and let's see, I just want to show you what a lane is. Let me comment this, the original initialize path call in setup, comment that out because it doesn't work anymore. Okay, so our lanes are going to be just how far a creep needs to travel before turning. So the first lane will be from the spawn point there to the first turn, and then the second lane will be from that point to the next turn. So yeah, it'll just keep following lanes until it reaches the end. That's when the creep leaks, despawns, and all that kinds of stuff. So back at the classes tab, we're going to create a subclass for path, and it's going to be called lane. And it's so again, a lane is just going to store an integer for the end position, and direction for which direction it's traveling. And so the constructor will take in a direction, so direction, and also the cell coordinates, so a vector. So the direction we could just apply, but the as for the end position, we need to calculate that out a little bit, because the end position will be different whether it's up and down or left and right. So if the direction is up or down, whoops. So the reason I'm doing an if statement and not a switch is because in Java with enums you can't use enums for switches. So yeah, I tried that out and it was not working. So which is no big deal. We could just use multiple if statements. All right, so if it's up or down, then we'll use the y cell coordinates from the vector that we're passing in. So we'll say end position equals round cell size times the y coordinate, and then so otherwise, so this would be left or right. End position equals, actually that should just be one equal sign. So round cell size times the x coordinate. Okay, so that's it for the constructor. So now we're actually going to be using the path constructor to create all the lanes. So yeah, let's create an array of lanes called all lanes. And while we're here, let's create a vector for spawn position. So we'll just store the not the coordinates. Usually, like we've only been using vector for coordinates, but we're just storing the actual position in pixels using vector. So just we're going to be careful not to change the spawn position, not to increment it any, and to if we need to change it, then we'll change it altogether by creating a new vector rather than altering the one that we've got. Yeah, just so we don't get some weird results out of that. But anyway, if you didn't understand that, just follow along. Yeah. So let's see. All right, so we're gonna change the path constructor around a little bit so that we can create lanes within the same within that constructor. So checking my notes. All right. So we're going to create an array of directions, a temporary array called directions, and we know that it's going to be whatever our pathway length is -1, so length -1. And okay, so now each time that we actually figure out which direction that we're going, we could actually set the direction there. So here where it says path goes right, we could set the direction. So let's just extend this out a little bit, and then we'll do that for each of the other ones as well. So we're going to be adding lines. And up. Alright, so for path goes right, we're just going to add directions I dot or equals, so direct whatever index we're at, we'll just set the directions to equal right. So direction dot right, and then we could just do the same thing for each separate direction. So left, down, and up. Now, if you notice, this isn't the most efficient way of doing it, because we're actually setting them multiple times yeah, but you know, it's not that big a difference. This is only called once, and it's not a huge deal. I'm just gonna go with it. If you want to do things for optimum efficiency, feel free to change that around as you would like to optimize it. So alright, so now that we've got the array of directions, we could actually use that. And so we'll go down to after the for loops end. After this, we'll just say all lanes is your array of lanes equal to however long our directions array is. Alright, so now we'll iterate through the amount that we need, which is all lanes dot length. And this is just a one-liner, so we'll just say all lanes I equals new lane, and then so it'll just be whatever the directions index is, and our pathway index plus 1, because we're going to be checking it against the next turn, or we want it to end at the next turn. So yeah, let's make sure that this is while I is less than all lanes dot length. Okay, so let's test that out. Alright, yeah, so actually I'm gonna end this video here, and we'll pick up right at this point in the next video. Yeah, so check out sophican.com. All the sources laid out there. I know that it might have been confusing from your perspective, because we're hopping around, cutting and pasting code places, and just editing things that we've already gone over. So if you feel like you might have missed something, feel free to just pick up the source code at my website. But anyway, yeah, I'll catch you guys next time, and we'll continue from right here. See you soon.